everyone. Thank you so much for being here. My name is Lollie Dixon. Today I'm going to be talking about the Pythagorean theorem. And I just want to ask, do any of you know how to use the Pythagorean theorem or know who actually utilizes it? Okay. If not, that's okay. Hopefully by the end of this speech, you will. So the Pythagorean theorem is an important tool used in modern day physics, engineering, and it is to this day one of the greatest contributions to the world of mathematics. I personally am very fond of math, and after learning about the history of Pythagoras in a philosophy class, as well as being able to apply his theorem thanks to a college algebra class, I finally understand why his theorem is so important to physics, mathematics, and engineering. So I will talk a little about Pythagoras. We'll look at some professions that actually use his equation, and finally I will demonstrate to you a simple version of his equation. So we begin by looking at the philosophical life of Pythagoras. The following information was taught to me by my philosophy professor and scholar, Mr. Tim Cowan. In the years 634 to 548, a question was asked: what is everything made of? Pythagoras dared to answer this question, saying that everything was made up of numbers and ideas. Now, this led to his vision of a two-world view, where in our world we would have our bodies, our souls, senses, and of course objects. Now, in the real world, it would be made up of numbers, thoughts, and of course ideas, and making it basically perfect. Unfortunately, our world is not so perfect. But you had to live the Pythagorean way of life in order to get to the real world, which is a life of contemplating numbers and practicing self-denial. When doing so, you could enter the real world and have the opportunity to practice mathematics for all eternity. Now we're going to look at some professions that actually use the Pythagorean theorem. This equation is used by so many people with a variety of professions in order to fix and solve problems. So, for example, an architect, an engineer, a carpenter, and so many more use this equation. According to an online article written by John Zamboni, states that when you find the length of a side, given the length of the other two sides, makes the Pythagorean theorem an important technique for navigation and construction. Now we're going to look at a simple demonstration of how to use his equation. So when looking at the equation, it's a squared plus b squared equals c squared. And when you look at the triangle, you have three corresponding sides, all labeled A, B, and C. Now in this scenario, you don't know what the slant or hypotenuse is. And we know that A is 3 and B is 4. Now when you plug it into the equation, you take your A, which is 3, and make it 3 squared plus 4, which is your B, squared, and then your C squared, which we don't know. So when you have a number that's squared, you basically multiply it by itself. So 3 times 3 equals 9, and then 4 times 4 equals 16. When you find those two numbers, you bring them down and you add them. So 9 plus 16 equals 25, and then you just bring down your c squared. In doing so, you still have a squared left over, and you have to get rid of it. So in doing so, you take the square root of both sides. When you do that, it simplifies the answer on this side to equal c and cancels out your 2. Now, when you do it to this side, it simplifies to 5. So the square root of 25 is 5. When you get this answer, you have just found the missing side of your triangle. For a more personal example, you can find the size of your TV using this equation. Thanks to Geoff K, he points that out in his website. In conclusion, we looked at the philosophical life of Pythagoras. We looked at some professions that use his equation, and finally we saw a simple demonstration on how to use his equation. I would just like to thank you once again for coming, and I understand that math is not everyone's subject and it can be difficult, but hopefully you learned a little bit today, and thank you so much for coming.